to talk about describing data. And our primary focus is on frequency distributions. Of course, we're going to talk about a few of the other graphics, such as pie charts and bar charts also. Now, as far as what we do with, or as far as how we represent data, how we summarize and present it, it depends on whether we have categorical data or qualitative data, and whether we have quantitative data. So, in this segment, the first part, I'm talking about displaying and organizing qualitative information. Okay, so what I've done here is I've made up this is a sample of my statistics courses. I just took let's say a sample of whatever size that is from one of my classes, my statistics classes, and these are the grades. Okay, now, and we're gonna think of this as a sample, a subset of a population. Okay, and if I recall correctly, there are 20. Yeah, there are 20 because this is a sample of size 20. So I have 20 scores. Notice the kind of information this is. This is nominal, correct? But then we can actually turn it into ordinal data, couldn't we? Remember, a letter grade of C is better than a D. D is better than F. B is better than C, better than D, better than F, and A is better than all of them, right? It's the best that could happen. So the letter grades are examples of ranking or ordinal data. So what can we do with this kind of data? Either way, whether you think of it as nominal or ordinal, which ordinal is what they are, it's qualitative. So with qualitative information, we can actually create frequency distributions. We can turn them into relative frequency, and as far as the visual goes, I have a couple of most common ones that's also in your book. We can do pie charts and bar charts and just about it. Notice we cannot do any formulas or anything sophisticated with these. So first we're going to take a look at frequency and relative frequency distributions. Okay, let's take a look at those. So here's an example of frequency distribution for those letter grades A, B, C, D, F. Notice I put them in the order from high to low. Next to that we have frequencies. So these first two columns make up what we call a frequency distribution. A frequency distribution shows the distribution of the scores across the values or levels of the variable. The variable is grade. The levels or values of it are A, B, C, D, F. And these are the counts or tallies or frequencies across those levels. Now we can turn these into relative frequency. The word relative here means relative to the sample size, which is 20. So a frequency of 5 relative to 20, 4 relative to 20, 6, and so on. And if you do a simple ratio of 5 divided by 20, you get 25%, right? 1/4. So 25% of the scores were A's. 20% were B's. Now note, by the way, as we go forward, we tend to stay with relative frequencies because these tie directly in with probabilities. So, and it makes sense also, not only as far as probability goes, it also makes sense to think in terms of percentages for most of the work that we do. So for example, let's say this is my statistics class and a student is about to take a statistics course, and it makes sense that they may be concerned, well, what do I expect to get in your class if I'm an average student? So if I told the students, well, 3 out of 20 of my students get D in the class, or if I say 4 out of 20 get B, typically we don't talk in terms of absolute numbers. We talk in terms of percentages. So if I tell the student 25% of my students get A in my class, then they can say, okay, well, I can relate to that better than if I told them 111 out of 794 get A. So we tend to stay with relative frequencies. Now, one thing you note here, that sum of all of these percentages or decimals or fractions, as a fraction, they should add up to 1. As decimal, they should add up to 1. And as a percent, they should add to 100%. Okay. And here I've done a pie chart. Now, don't worry, I'll show you with an example later on. By the time we get to chapter 4, means we finish with this week's lecture, we'll do an example where we go in both Minitab and we go to Megastat to do this. Again, for those who have a Mac, you have to purchase a Minitab in order to be able to do things with a computer. Otherwise, you got to do it by hand. You don't want to do that. And the reason it's turned that way is because actually in a face-to-face environment, we would meet in a computer lab in one of the regional centers, let's say Temecula or San Diego, whichever you belong to. And on those computers, they all have Megastat installed on it. So there shouldn't be a problem because we're using the center's computers, not your Mac. But being online now, unfortunately, that's how it is. You just cannot download Megastat for Mac. Anyways, so here's a pie chart. The pie chart tells you exactly what the relative frequency says. It's just another way of presentation. This one as color is visual and looks nicer. But if you note, you have exact same information that was in the frequency table. You have it here. Look at that. This is in fact a relative frequency table right next to it. A, B, C, D, F. Frequencies, relative frequencies. And there you have it. Now in this example, the C category with 30%, C is the largest slice of that pie. The smallest slice belongs to F, only 10%. 2 students got a failing score. So there is your pie chart. And the softwares, of course, handle these. Then we look at the bar chart. With bar charts, you look at, it's just another way to present this data. Instead of pie chart, now we have a bar chart, but they both again impart the same information to us. Now here I have several bar charts. This is a relative frequency bar chart. Actually it says relative frequencies, but they are, because see the percentage here, the word percent up here, that means these are relative frequencies. So 25%, 20, 30, 15, 10 there. Now this is ordinal data, A, B, C, D, F, and so this is the distribution of grades, let's say in that class. Okay, and you can look at bar charts of grades. This time is in terms of frequencies, not look up here. Up here it was percent. Relative, it's not the relative, it's just counts 5, 4, 6, 3, 2 as opposed to percents. But look at the shape of these, by the way, folks. Look at the shape of these two. They are identical. So it makes no difference whether you use frequency bar chart or relative frequency bar chart. We tend to go with relative frequencies. Now, here's just to show you different options on how we can do our bar charts. This one is ascending order by count. 2, 3, 4, 5, 6. There you go. F, D, B, A, C. Notice when we order them by count, the order of these letter grades change. But that's okay. The information doesn't change. If you look up here, the greatest category was a C category with 6 students in that category. Here, it gives you the same information, except you get a nice visual. You can see just another way to present this data. If you want, we can show it in descending order by count. See that? In all 4 charts, you can see the C category has the lion's share of the distribution of grades. Okay. Now, Again, I want to emphasize that frequency and relative frequencies, these two are identical. They don't look any different. Now, what if I have, so that's all just about it. With qualitative data, categorical, those are the kind of things we do. Now, what can I do with quantitative data? That's what this one is, right? How can I display that information? So with quantitative data now, you can do everything you do with qualitative, okay? And then some. When you can do more with quantitative, okay? So here it is. Generally speaking, anything that you do to qualitative, you can do it for quantitative. Now these are the scores actually, right, that I had for these students, the 20 scores, the letter grades, and these are the scores that are corresponding to those. I'm not saying C is 35, D is 99. They're not in the same order, but they're the same scores. Now, what I could do is I could actually now group these in categories. See, notice I have quantitative data, right? This is quantitative. But I have created categorical categories, right? Qualitative categories. And I created the letter grades A, B, C, D, F, and there you go. I get exact same information had I been given this rather than the A, B, C, Ds from beginning. Okay, so that's interesting. I'm just showing here that you can do with quantitative what you did with quantitative, with qualitative qualities. Now, the other thing we do with quantitative that we do not do with qualitative is construct histograms. Histograms are typically from low to high. The value of the variable are starting from low, they go all the way to the highest. And then this one, you're looking at again the actual frequency of scores, 30 to 40, 50 to 60, and so on. Notice there is a gap between 40 and 50. Usually we do not like gaps in our histograms, but this one I just have one that's fallen off the crack. And one thing, by the way, let me mention, folks, the sample here is 20. It's not that impressive. So my histogram isn't that impressive either. Generally speaking, with small samples, your visuals look poor, they don't look that great. And the numbers that we actually calculate in our computations, although we can calculate them, but they're not going to be as accurate as if I have bigger samples. With bigger samples, everything looks better. The visuals look better and the findings are more genuine. So just want to point out the pitfall of small samples. Now, now what do we look for in a histogram? Typically, in a histogram, we look for trends. Okay. So, for example, if I was to draw a trend line over this, it's going to look like that, right? So I can say that the distribution of grades is somewhat ever slightly skewed to the left, right? We'll talk about skewness in a few minutes, but that's what that is. We usually smooth over these histograms and try to, in our imaginations, in our minds, we would like to get the idea of a smooth curve over the data. Okay, now here I have some guidelines for how do we construct histograms. Again, make sure you avoid empty classes, try equal width classes as much as possible, and of course be very careful because these classes must be mutually exclusive and collectively exhaustive. What do we mean? Mutually exclusive means this. See these categories, 90 to 100, 80, 89, 70, 79, there is no overlap. So for example, this category doesn't go from 70 to 82 and then this goes 80 to 89, because if you can kind of see, right, what could happen if you have overlapping categories. An observation could be placed in two places, and that would result in duplicate counting, and it throws everything off. So mutually exclusive means disjoint categories, and collectively exhausting means the minimum score is going to be there, the maximum is going to be there, and everything in between. Every score has a place, unique place in that frequency table. Now, as far as the shapes of frequency polygons here, as your book calls it, as of these, the shape of a histogram goes, these are typically what we're looking at for shapes. We're looking for symmetry. The symmetry doesn't necessarily have to be this idea of bell shape. I could have symmetric U distribution, that's symmetrical. Or I could have, let's say, a triangular distribution that's symmetrical about the center. Okay, so but usually we look at this kind of symmetry, kind of a normal distribution. Okay, now the other kind of distribution here we look at in a histogram is that of a skewed distribution. This one is skewed, and in this case it is right skewed because it tapers on the right side. You see that? So that's why it's skewed right or positively skewed. With respect to, let's say, the test scores, in the book's example, the test scores are left skewed, just like mine was. Look at the one I look at from my class. See, that one is left skewed, and so was this one. So again, in a histogram, we generally look for trends, and we also look for outliers. Okay, and what do I mean how we do that? Let's say if my histogram, once I smooth over, it looks like this. Sorry, I know that's sloppy, but that's okay. I'll erase it anyway. And then look at this. I have this one category which dragged the tail all the way towards itself. So what we do also is we look for outliers in the distribution. So there you go. That score is an outlier, or that whatever category that makes up, scores that make up that category, that shows an outlier, presence of outliers. Okay, so we look for trends, we look for outliers, and the general shape of the distribution is what we're interested. Okay, and that is all we have in this section. Now again, don't worry, I will look at a data set and we will take a look at Megastat and Minitab on how we can actually create these histograms, pie charts, and all that. That's all we talked about for our visuals so far. And with that, we are done with chapter 2. And our next chapter, we're going to see some formulas in the next chapter. So that concludes this video.